Yes friends, as part of this session, let us understand about one more modifier which is called as strict FP. Okay, simple thing we are going to get understand this one with one important code. Okay, now what is that modifier? Strict FP. Okay, introduced at 1.2 version. Okay. Yes, mister, why we have to go for this particular strict IFP? It's not having any internal implementations, okay, by Sun Micro system. They didn't provide any implementations. Like, what is that internal implementations means? Try to observe here. If there is a class with a final modifier, what is the meaning of this class? You cannot inherit anything from this class, right? Observe here, okay? You cannot inherit anything from this class. What is that? Void M1. Let it be the implementation as what? Something, okay? Something, okay? Now, child class creation is not possible. Getting? Yes, friends. Why it is not possible? Because of this final modifier, okay? It's having, that is final modifier is having some internal implementation. That's why you're going to get what? Compile time error as what? What is that? F is the final, cannot inherit from it. Okay, so these things are what? Some of the internal implementations. Like that, we don't have any internal implementations for this strict FP modifier. Okay, if it is so, if it is having any internal implementation, please let me know. Okay, now let's go for this implementation. Okay, to my knowledge, there is no internal implementation for this strict FP modifier. Okay, now observe this one, okay, properly. What's the meaning of this one? Okay, and you have said that it's a modifier, but not what? Access modifier. Okay, what is that? It's a modifier, okay, which is applicable, or you can write this modifier for classes and for a method. That is, you can write this modifier at class level, and also you can write this one at method level. Observe here, okay, and can be used at class level and at at method level. Okay, at method level. One more very important, and you guys are aware of this one. If you want to give just the method declaration but not implementation with how we are going to inform this information to compiler and JVM? What is that? I just want to give the method declaration, no method implementations. I just want to give what? Method declaration. About this method, how we are going to inform to JVM and compiler, like it is having just declaration by using what keyword, or by using which modifier? That is abstract. And this is the modifier which always speaks about declaration, but no implementation. Talks about declaration and no implementation. That is, it's not at all having opening and the closing scopes. Okay, these two scopes represents the area where you want to write your instructions or your main logic. Okay, project or application required logic. Okay, now observe this one carefully, friends. Okay, observe this one carefully. Only abstract is the modifier which talks about declaration. Okay, now so strict FP always talks about method implementation. Okay, it always expects what? Method implementation. Okay, at method level. Okay, at method level. Now we are going to discuss even at class level. First, let me talk about that method level. Okay, at method level. Okay, at method level. Observe carefully. Okay, if if you want a particular arithmetic floating point outputs which is independent to the platforms. Observe here in our Java we are having fractional outputs, that is after decimal or after dot. Okay, after dot. See here 991111. This is called as what? Integer digits. Okay, and this one is called as what, friends? Fraction digits. Okay, fraction digits. All together is called as what? Floating point literal. Getting in our Java? Floating point literal. Okay, floating point literal. Okay, observe this one. According to our predefined data type float, according to our predefined data type float, what is the internal implementation for this one? What is the exact implementation given by Sun Micro system? If you want fraction digits till 5 or 6 digits, then you can go for what? Float data type. Okay, fraction digits, what is that? Fraction digits up to 5 to 6 digits. Okay, up to 5. Then we can go for which one? Float data type. Okay, float data type. If it is like double, same thing, fraction digits up to 14 and 14 to 15 fraction digits, friends. Okay, fraction. Okay, fraction. Yes, good, fine. If I do run our Java dot class file at 16-bit processor, okay, operating system, and if I do run our Java code at 32-bit, what will be the output for this float and double data types? There you are going to see some platform dependent outputs. It will give what? It will give what? According to us, if it is like float, it will give what? 6, and if it is like double, it will give what? 15. And if you do notice these two things, it will get vary from one operating system to other operating system. Here in double, 16th digit is what? A rounding digit. Here 7th digit is what? A rounding digit. Okay, so you are going to get what? For float and double, of course, in our applications, in our real-time applications, if you are having any fraction or floating point digits, okay, more than 3 fraction digits, you are going to consider only two fraction digits. Okay, so if you want to give such type of outputs, I want to inform to someone, hello mister, I don't want the exact value. Of course it can do get extend to 1 million also. What's the value of pi? What is the value of pi? 1.34, but it is not 1.34. If you do extend this fraction digits till to million values, okay, still we are not having exact value to the pi. That's why after dot, after decimal digits also, some of the mathematicians are trying to find the value for this pi. Okay, so if you want the output up to some fraction digits, I don't want to get this thing 6, 15, all of these things, whatever the data type it is, float or double. I just want the output. I just want the output for 4 fraction digits. 4 fraction digits, whatever the platform it is, whether it is 16-bit or whether it is 32-bit, I don't bother about that one. I just want the output which is platform independent one. Then you have to intimate to the programmer technically. How? Means simple thing. That method should be declared as what? Strict FP. Then he should follow IEEE 754 standard. Getting or giving an output with 4 fraction digits is IEEE 754 standard. What is that? Giving output for, okay, giving output for floating point literals, getting for floating point literals up to 4 fraction digits, 4 fraction digits is following IEEE 754 standard. Okay, that's it. If you want to make a particular method implementation to give a floating point literal with fraction digits up to 4, then you should go for a strict FP modifier. It doesn't have any internal implementation. Okay, please try to focus. Okay, now please try to focus. This is with respect to the method. Let us see one small example. Internal implementation of this one. We are the code writers. We should be very strong enough to write the logics, whatever the requirement it is. Right? You guys are having the knowledge in this one. Just a small slight changes will be there. Than that, nothing. Please observe for a while. Okay? Let us write the code for this. Okay? Now observe this one. Okay, think that I have a class A, getting I have a class A. Okay, now I have declared one method m1 which is going to accept the argument as what? Double. Now I declared this class method as what? Strict FP. Strict FP means what? This person who is providing implementation for this method m1 has to follow what? IEEE 754 standards. What is that standard meaning? That person must and should give the floating point output with 4 fraction digits. Think that double value one of my friend is passing with that double line 1 up to 15 ones. Okay, up to 15 ones. Okay, up to 15 digits. Okay, or else any 10 digits, whatever it is, or up to 10 digits. Okay, or up to 10 digits. Okay, now observe here. I want to give the output in 4 fraction digits. Let us make this return type as what? A string. Okay, let us write the return type of this particular method as what? A string. Okay, this was the input for this particular what is that? Method. Okay, now observe here. Now we have to check that whether it is containing after dot how many number of fraction digits. Simple thing, please try to observe here. This is what, friends? Literal, double literal. I want to convert this particular thing into string. To which method we have to go? Of course, you can write the logic for that one to convert this primitive into the, that is primitive literal into the string. If you know the OS related knowledge, getting very specific thing. Okay, observe here. What is that means? I want to convert this into the string type. Okay, I'm going to convert that into the string type. Simple thing. What is that? A double dot to string. What is that? It always expects what? Primitive, a literal as an argument. Its return type is what? A string. Okay, now let me hold that one into one of the string literal. Okay, done. We have done. Okay, we have done with this one. Simple thing. Now before going to the exact logic, let me tell the oral logic and let me convert that oral logic into the technical thing very slowly. Okay, yes mister, we know that double line 111 up to 10 digits, right? 10 digits. I want to delete the ones which are there after 4 digits. I want to delete them. Okay, I want to give the output in which way? Double line point 4 ones. Yes, right? Yes, right? Yes. You have to delete that particular thing. How we can do achieve that one? In which class we do have deleting a particular index, a string element. and that should get deleted from starting to the ending. We are having such type of service or a method within the string buffer class. Okay, we are having one method in our string buffer class as what? Delete int start index. Other one is what? Int n-1 index. It is going to delete a particular element from start index. I mean, it is going to delete the elements from given particular start index to the n-1 index. Okay, please try to observe here. Okay, I am going to use this one. Okay, I am going to use this one. Okay, now observe here. Okay, observe, we have gotten each and everything in string type. Observe here, let me take one of the local variable I equals to 0. I mean, double value can be in which format? Of course, I have given just 2 digits, 2 decimal digits or integer digits. Tomorrow one of my friend has come and he has given 9 times 99111. And now how to find that particular dot and how to delete all of those ones? Simple thing, you have to, we don't know this value, right? We don't know that integer digits. So what, in which to approach this one? If we don't know the number of options in advance, means you have to go for one of the conditional controlled statement. What is that? While iterative statement, or else you can go for loop also. Okay, now let me take while loop. While I is less than s dot length. Okay, I is less than s dot of length. How to get a particular index character? By using one of the method called char at method. Okay, it is going to give return type as what? Char, which is available within the string class. Okay, now observe here, observe this one properly. If s dot cat of I equal to what is that? Dot, till dot I should go, I should make the JVM to traverse. Think that JVM is at the second index. Please observe, friends. Okay, observe. Okay, now index. Now after dot, I know that we have to consider how many fraction digits? Just 4, right? Just 4. What is the value of I here if this condition is getting satisfied? Means, yes, what is the value of I if this condition is getting satisfied? Means value of I will be always as what? 2. And you want just 4 fraction digits. Okay, you have, you should get only 4 fraction digits. So how to get this 5 here? Okay, 4 3 5, and this is what? 6. Now how to get this 6? We can do access all the characters by using index values only, if it is like a string or if it is like an array. Now observe here, how to get that 6? Simple thing, I equals to I plus 4. So 2 plus 4 is how much? 6. We are getting 6. Now let us do that thing. Okay, I is equals to I plus 4. Okay, I plus 4. Just break it. I don't want to perform any of the iterations here. Now what is the value of I? It is what, friends? It is what? 6. Okay, let it be, it is what? 6. We have to delete from 5th index, right? We have to delete from 5th fraction digit, right? From here onwards you have to delete. Okay, 0 1 2 3 4 5 6, and from 7th onwards you have to delete. Okay, now let me put this one as what? 5. It's not 4, friends. Okay, let me take this one as what? 5. So if I do put 5, what will be the value? It will be 7. Okay, same thing, nothing is changing here. Okay, now observe here. Okay, now we have come out of the while loop. Try to observe this one. Do we have the delete method within the string class? No, we have that method within the string buffer class. Okay, we are having that method within the string buffer class. So how to convert this particular string object to the string buffer? Simple thing. We are having some few constructors. Let me take one of the string buffer constructor, which is having argument as what? Char sequence. So char sequence is the parent for string buffer and also for the string. So I can pass the string literal. Okay, now on this just delete sb dot delete of what is that? What is that, friends? What is that? I value comma s dot length minus 1. Why length minus 1? This one. Okay, till the end I have to delete. Okay, try to observe here. If I do delete, what will be the output? Definitely you are going to get this one. Okay, we are going to get this one. Finished, nothing. And of course you want to return this one, you can perform once again toString method operation, getting, or else you can do parse double method also to convert that into the particular floating point literal. Please try to observe here. Let me take this one as what? Double itself. Okay, let me take this one as what? Double. How to do that one means simple. Observe here. This is what? ESB. We are having what is that? Parts double, getting parts double, which is the static method in our double class. So it always expects the double within of which format? String format, not string type. It always expects the double literal value in string format, friends. Okay, so it is going to return what? Primitive double literal. So it is going to return what? Primitive double literal. It is what? A static method within the double class. Now I am going to use that one. Okay, observe here, parts double. Now observe here, our wanted information available with whom? String buffer object. I want to convert that into the string type. How we can do a string format? It expects what? Always a string. Okay, string format double literal. Okay, double literal. How to do that one? Simple thing. You have to use one more time the constructor. Observe here, new, we are having within the string class one constructor, getting, having argument as what? String buffer. Okay, now observe here, our information is available with whom? With SB. Okay, now put SB. Okay, and this one is what? A double, right? Now let me which is static method within the double. Now let me put what? Directly return, and there ends the method m1 implementation. That's it. Okay, observe here. Okay, observe here. Now let me take what is that? One of the driven method to test this one. Okay, to test this particular piece of code. Okay, now observe here, public static void main. Okay, what is that? What is this? A equals to new A. Okay, now A dot m1 of 99.111111 tell some digits. Okay, now it is going to return something to us, right? Yes, it will return something to us. Let me put that one within the SOP statement. Very specific thing. Okay, you are going to see the output. In which way? In which way you are going to see the output? The output for this one will be up to 4 fraction digit. Yes, we are following IEEE 754 standard to give the output up to 4 fraction digits. Very important. Just for a while, I am going to compile and execute this piece of code. Just a fraction of second. Okay. Yes, friends, observe here the same piece of code whatever I have written overboard. Okay, same thing. Okay, one driven method to test that one. Okay, same piece of code, nothing changed here. Okay, you can just observe this one. Okay, and one small change is what means here 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 it is if we do give what is that in this delete method, right? In this delete method, it always taking an index which is given to the start index plus one value it is considering. Okay, here the start index plus one value it is considering. So to get our output you have to put this one as what? 4 only, just that change, than that nothing. The logic each and everything is same. Thing is what? Internal or the predefined method is having some other behavior. Logic is not changing. Please observe this one carefully now. Okay, now observe this one carefully. Okay, now everything is fine, friends. Whatever the code we have written over board, the same thing. Okay, same thing, nothing change. Okay, you can even test this code. Okay, now let us go and compile this one and let us test that one. What is that? strictfp. The source file name is what? strictfp demo.java. Let me compile and let me run this piece of code to test this particular piece of code. What is the corresponding main method class name? Here it is the main method. Okay, main method corresponding class name is what? Driven. Now let me put this driven. Okay, now let us compile. Observe here, I am passing how many ones here? More than 4 ones. We should get the output up to 4 fraction digits. Okay, observe here. Okay, yes, we are getting 4 fraction digits. Okay, very specific one. Okay, okay, through code we have proved this. We have proved this strictfp modifier. Okay.